So for this topic, we're going to be talking about how, given a collection of data, usually represented as a scatter plot, we can use the correlation coefficient called R to determine whether it's positively or negatively correlated, and how we can use the coefficient of determination, R squared, to see how well a model we come up with is going to fit this data. So first of all, let me just go ahead and throw up some random points on a scatter plot. Okay, and we'll take a look at this guy. So first of all, the thing you have to understand about R is that, actually, one moment. Let's say this is the x direction. Let's say this is the y direction, just for some arbitrary data. And so, first of all, R could be either negative or positive. And so what does it mean either way? Well, for R close to 1, that means we have a positive correlation. So as one thing increases, the other thing increases as well. If we have R close to -1, this means that the data we have, as one increases, the other decreases. So this random one I threw up right now, if you look, as I start over here, my x value is small, but my y is fairly large. And as I start increasing the x, even though these points aren't very close together, they do all start to go down. So a perfect example, if I had an R of exactly -1, would be something like this. All the data is perfectly going down. As I go this way, the data goes down straight through. And so we could have just a straight line that goes through that. So this graph I just drew here would be an example of R equals -1. All the data is negatively correlated perfectly. Likewise, for R equals +1 perfectly, I could have data I can do a straight line through that, and so that would be an R equals 1 situation. So over here, for this random scatter plot I have of all these points that are sort of going down, let's say we tried to put a line through here. Well, I can't do a ziggy-zaggy line that's all over the place, so I want something smooth and continuous. So if I'm just guesstimating here, perhaps something like here. So notice this is about as close as I can get to the most points, right? If I moved it down, I'd be too far away from all these guys. I may be kind of far from this point, but it's okay because I'm so much closer to all the others. So if we look at this, it is a negative correlation coefficient because it's going down. So I know it's R equals negative something. However, because the data is spread out like this, it's not perfect. So it's not a -1 like this was. And so if I were to estimate this, I'd say like 0.75, -0.75. So it's 75% negatively correlated, such is my estimate anyway. Now, say I wanted to judge like how well this line fits that data. Well, if my correlation coefficient for this is indeed -0.75, what I can do is square it, and this is going to give me a value that tells me how well it fits. So if I do that right quick, if I just do -0.75 squared, I'm getting 0.5625, which would usually be expressed as a percentage, so this would be 56.25%. And so what that means is that 56.25% of the data will actually fall on my regression line right there. Now notice that if I have a negative number and I square it, it becomes positive. So since R is always in between -1 and 1, when I square it, R squared is always greater than 0, because when I square a negative number, I get positive. And it's always less than or equal to 100%. Those could be equal as well. Not very likely, though. So let's look at another random scatter plot. I'll just throw up some other points. Okay, so there's some random points thrown up. And if I look at this one here, and I try to do a line of best fit, maybe I could do something about through here and try to keep it straight. Okay, this is a positive correlation. This one was negative because they were all going down. This one's a positive correlation. Now, if I look at that, this one, I had a cluster of values up here, so perhaps this line should be a little bit closer. That would give my correlation coefficient of 75% negative. This one, I tried to make the data spread out a little bit more, so I've got more outliers. Like this guy's flung way over here, this guy's flung way over here, this guy's flung way over here. So if I were to estimate this, I would go with maybe 0.68 or 0.7, something like that. So I'll go with 68%. And again, these are estimates, but it looks like this is about a 68% positive correlation. Let's see how well my line fits that, if it is indeed 68%. So if I do 0.68 and I square it, my r squared is 0.4624. So notice how, and if we write that as a percentage, that's 46.24%. And notice that's less than the percentage we got over here. And that's because my correlation coefficient, my 68%, was less than 75%, of course. But the reason this was less is because I have more outliers here, right? Perhaps to make it more accurate, there should be even more, and I can like put one guy over there and then one way over here, something like that. And so since this has more data that's not close to the line, that's not fitting the line, less of the data that we actually observe is going to fall on this regression line, only 46.24% of it. Now, as a final thing, what if you have something totally chaotic? What if you have something that looks like this? Well, I guess that's not that chaotic because it looks pretty symmetric, but try fitting a line to that. If I try to be perfectly on this line, this dot, well, I'm very far away from this one. So maybe I should come up here. Well, now I'm really close to this. I'm pretty far away from both of those, so that's a little bit better. So perhaps I could just do a line right through here. That lets me get right on some of the lines and be perfectly far away from these other lines. However, is there a positive or a negative correlation either way? I don't seem to have anything where if I go this way, the values are increasing. In fact, I just have a perfect amount of increasing and decreasing in both ways. Likewise, if I try to go down, that doesn't seem to work. And you see that if I try to draw other lines through here, I'm always going to have points that are much further away than this. So this, because I'm not having a negative or a positive correlation, you could just say this is a correlation coefficient of 0. Now what's interesting about that is if I square this, I get 0. So that's 0%. That is interesting because the way I drew this, it does go through some of the data. What's going on is that we're saying 0% of the data falls on our regression line, I should say, because every time I hit one point, I'm missing 2, right? And if I added even more points, right, every time I hit one of these data points, if I added more and more that are further and further away, I'd be missing, dozens of data points. So these are approximations. The point of them is that this is how correlated you are. This one's pretty intuitive. That's not correlated at all. And so if I'm not correlated and I try to calculate how good my fit is, I'm not going to get a very good percentage. And so there we go. That was an example of scatter plots, correlation coefficients, and coefficients of determination and what they mean.